Good morning. Yes, we are studying squares and square roots, isn't it? So, few properties you have learned in the last class, interesting patterns, everything. 3 points we have learned. That is, sum of odd numbers is the square of the number of odd numbers you have taken, isn't it? About a triangular numbers you have learned. Today, let us discuss some more points, children. That is, the sum of consecutive natural numbers. How to write it? So we already know that 3 square is nothing but a 9. So 9 can be written as sum of two consecutive numbers, that is 4 plus 5. Okay. 5 square is 25. Even 25 can be written as sum of 12 plus 13. They are consecutive numbers, natural numbers. Isn't it? So 11 square is 121. That time also 60 plus 61, add it, you will be getting 121. So this is the one more property. Now the one more interesting property of this is the product of two consecutive even or odd natural numbers. Okay, even or odd natural numbers will be, see, this is the thing. 11 and 13 are the two consecutive odd numbers. Okay. So, between these numbers, which is the number that is lying? That is 12, isn't it? So, between 11 and 13, we are having a number 12. So, take the 12 as a base, subtract 12 from 1 and add 12 for 1. That's at time it will be 12 minus 1 into 12 plus 1. Isn't it? So 12 is the common number. From that you subtract 12 square minus 1. That is 144. Minus 1 if you do, you will be getting a 143. It is 143. That is the answer you will be getting from multiplying 11 into 13. Okay. In the same way, bigger numbers we will take. 29 and 31 I am taking. So middle number between these is 30. So 30 minus 1, 29 can be written as 30 minus 1, whereas 31 can be written as 30 plus 1. So which is the common number in both? 30 square. That is a plus b into a minus b form. So a square minus b square, 30 square minus 1. So 30 square is 900, 1 square is 1 only. So 900 minus 1 is 899. See, by easy way, you can find the product of two consecutive odd numbers. Even you can take the same thing for even numbers also. This is the one more special property of square numbers. Getting? It is a plus 1 into a minus 1 is equal to a square minus 1. A plus b into a minus b form only, children. But always here we should get a 1. That is the speciality. Okay, now let us move to the one more pattern, very interesting pattern. See, by looking at this only we will be coming to know. So 1 square is 1, 11 square is 121, you are knowing. So 111 square is 1, 2, 3, 2, 1. Just observe, 2 is there, that side and this side 1. Again here we got 3, 2 on the both side, 1 on the both side. Next one more 1 comes means 4 you will be getting. It depends. The middle number depends on how many digits you are having here. See here 2 ones, so 2. 3 ones, 3, 4. So you can continue. If I take 1, 1, 1, 1, 4 times over, 5 times if you take, that time 5 will be in the middle. Remaining number should come. 4, 3, 2, 1. This side also 4, 3, 2, 1. Like this it will continue. Now you can go on writing the pattern here. Got it off now? Okay. Let us go with the one more pattern. It is not always these numbers. One more number we will take. Here I am taken 7 square. 7 square is what? 49 square. 49. 67 square is 4489. What is the special thing you are observing? See, 4 and 9. In the middle 48 you are getting. Again 667 square is, the 2 4s will become 3 4s, 8 will double and 9 will be left there. If you continue it, number of 4s increases. Okay, 8 increases. So this is the one more pattern you will be having. So these are the special patterns of square numbers. Now let us move to the exercise part. Okay, so the first problem of the exercise: what will be the unit digit of a squares of the following numbers? Here there is no need of squaring the numbers, children. Just they are asking what will be the unit digit of the squares. If you square these numbers in their unit place, what will be the number you will be getting? Okay. So in the last class I have given some properties. If you are having a unit place some numbers, what you will be getting in the square numbers I already given in the last class. Okay, let us recall that. Just I am giving that idea. So what is the thing you are having? Just check it out. See, if a number has 1 or 9 in the unit place, then its square ends in 1, isn't it? So if you are having 9, 1 or 9, so it should end with 1 or 9, it should end with 1. In the same way, 4 or 6 means what it should end with? It should end with 6. If you are having a 5, even it is ending with a 5 only, isn't it? And 0 means even it ends with a 0 only. Next, 3 or 7 if you are having, it should end with a 9. And if you are having 2 or 8, it should end with a 4. Okay, based on these properties, now you should solve this, children. Keeping that in mind, you have to solve that. Okay. Okay. Now, so what is our question? Just to check it out, children. Unit places 7. Just we'll go with the thing. So 3 or 7, what should be the unit place of a square number? 9. That you write down. Okay, again, unit place is 2. If a number ends with 2 or 8, what will be the unit place? 4. So square of that number will be 4. Next, if it is ending with 5, 5 only. If it ends with 3, 3 or 7 is again 9 only. Okay, on this basis you have to answer. Now let us move to the next one more mine. Okay, so already they have given the following numbers are obviously not a perfect squares. What the numbers you are getting here, they are not a square numbers. Okay, you have to give the reason why they are not a square numbers. For what purpose they are not a square numbers? Again, I am recalling one more property, children, here. So, you know that a square number should never end with these numbers. Which are that number? 2, 3, 7 or 8. That means in the unit place of a square number, we never get these digits. If these digits are present in the unit place, automatically you can say that they are not a square numbers. Now, what is our first question? 1057. What is the unit place? 7. It is one of the number from our list. Therefore, it is not a square number. Next number is this one. Okay, 2,22,222. What is the unit place? 2. Again, 2 should not come in the unit place of a square number, so it is not a square number. Again, we are having a 0. But in our list, 0 is not there. Then also it is not a square number. Can you say why? See, whenever we square, for example, 10 into 10 if you take, you will be getting 100. 100 into 100 if you take, you will be getting 10,000. Isn't it? So, here 100 means it doubles. 2 are there means it becomes 4. In the same way, just check the number of zeros. They are odd. Whenever if you are having an odd number of zeros, then it never becomes as a square number. Clear? So the next number is this one, 23,453. Check the unit place, 3. So 3 is in our list. That's why it is not a square number. Cleared? Okay. Next, we will move to the next problem of the exercise. The squares of which of the following would be odd numbers they are asking. Okay. So here you have to check the given number. Its unit, whether it is a even or odd, you have to check. 431. It is an odd number, isn't it? And we already know one of the property. A square of even number is even and odd number is odd always. So it is an odd number. So its square is also odd. This one is even. So it is the square of that number will be even only. So in the list other problems you will be getting in that which are odd, that one only you should say, children. Okay. Now next we will move into the patterns, children. So here one pattern they have given and they have left the blanks here. You have to fill the blanks. So 11 square is 121, 101 square is 10201, 1001 square is 1002001. Just observe here how many zeros are there that should come on the both the sides of 2. Here you check the zeros. How many are there? 1, 2, 3, 4. Here also it should be filled with the 4 zeros on both the sides of 2. On the right side as well as left side. Here they have given fully blank. So what it should be? 1. Check the zeros. 6 are there. 1, 2, 3, 4, 5, 6. After that what you have to write? 2 you should write. Again 6 zeros. 4, 5, 6. Next one. Starting and ending 1. Middle is 2. And both the sides of middle part 0 should come. The number of zeros depends on the number of zeros present in the question. Clear? Okay. Like this, some more patterns are there. You should fill it. Now let's move to the next problem. So here, without adding, you should not add it. You have to find the sum. How to do it? It is the one more special property of square numbers, isn't it? Just count down how many odd numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 odd numbers are there. Just square it. 12 into 12, 12 12s are 144. Okay, so the sum of these numbers will be 144. You can take your calculator and add it. You are getting the same total, children. Okay. Now, the reverse of they have given one more problem. Express 49 as the sum of 7 odd numbers. Reverse. They have given the sum. You have to express it. So, sum of how many odd numbers you have to take? 7. Just write down 7 odd numbers. 1, 3, 5, 7, 9, 11, 13. So, add plus between them. Check out how many numbers are there. 1, 2, 3, 4, 5, 6, 7. Add it, you will be getting 49 only, children. Okay. Now, the next problem. Last problem of the exercise. How many numbers lie between the squares of the numbers 12 and 13? So, non-perfect square numbers you have to find. We are having a formula, children. There will be 2n number of numbers between n and n plus 1. Here, which is n? N is equal to 12. N plus 1 means 13. So, 2n means 2 into 12. So, 12 2s are 24 numbers you are getting. So, you can check it out. 12 square is 144. 13 square is 169. Write down all the numbers between 144 and 169 and count down it. It should be 24. Okay. That is the work I am giving for you. Okay. So, this was about the special properties of squares and square numbers. Now, we will move to the one more concept of the lesson, that is finding the square of a number. So, a number will be given. You have to find the square of that number. For example, small numbers if you take 3, 4, 5, 6. What is 3 square? 3 3s are 9. 4 square 16, 5 square 25, 6 square 36. Easily you can say it off, isn't it? But if I ask what is the square of 53, can you say in the same way how you have said here? No, isn't it? Then how to find? How to find the square of that? It is one method, multiplying 53 two times. But it takes more time. Instead of that, we can go for an easy technique. What is that? Means splitting. 53 you split as 50 plus 3. So 53 square we have to find. So whole square you will get here 50 plus 3 whole square. So a square can be written as a into a, isn't it? Here also 50 plus 3 whole square can be written as 50 plus 3 into 50 plus 3. Split it. 50 into these two things plus 3 into this. This into this full thing and this into this. Now 50 into 50, 50 square. 50 into 3 again. Plus will be there. 3 into 50 plus into plus plus 3 into 3, 3 square. Very easy to square it. 5 5s are 25. 1 0 will become 2 zeros. 5 3s are 15. 1 0. So same thing. 50 into 3 is similar to 3 into 15. 150 only you are getting. So 3 square is 9. Add all. 2500, 150, 159. 9, 5 plus 5, 10. 1 carry. 6, 7, 8, 2. So the answer is 2809. Okay. This is one way. There is one more thing, children. If any number ends with 5, then even it is very easy to find the square of it. How? Just see, you are having a 75 square. So, take the 7 and the next digit of a 7, next number of a 7. After that is successor of 7 is 8. That you write down, those many hundreds, and square it. Unit place your square. 5 square is what? 25. Okay. So by multiplying 7 8s are 56. Hundreds they are given. Hundreds will contain how many zeros? 2 zeros plus 25. Add it off. So you will be getting 5625. This is similar to 75 into 75. You can check it out, children. 5 5s are 25 to carry. 5 7s are 35. 2 37, 7 5s are 35, 2 7 7s are 49 plus 2 is 51. 49 plus 3 we are getting, children. 52 we are getting. 5, 12, 6, 5. See, the same answer we got here also. Easy, no? Yes. One more big number we will take. 125 square. 12 you take down. Split it 2 parts. 12, which is the successor of 12, 13. Those many hundreds. 5 square is 25. So, 12 into 13 is 156. Zeros you added off 25. By adding you will be getting 15,625. Got it off? This is the one more method. So in square numbers only we are getting the one more concept, that is Pythagorean triplets. What are these Pythagorean triplets? Actually, the Pythagoras theorem says that, so in a right angle triangle, this is the hypotenuse, children. The square on the hypotenuse is equal to sum of the squares on other two sides, and that is AC square will be equal to AB square plus BC square. Okay, that is the concept. If you are taking 3 numbers, the bigger square number should be equal to sum of the squares of other 2 numbers. Let us check it out that. 3 square plus 4 square you make. 3 square is 9, 4 square is 16. By adding what you are getting? 25. Now which is the bigger number? 5. 5 square is what? 25. See, both are same. Such a numbers which satisfies this property, they are called as Pythagorean triplets. Okay. What we call them as Pythagorean triplets we used to say. Now, like that many triplets we are having, 6, 8, 10, 5, 12, 13, like that. Many we will be having. So in general, how we can say that? This number should be always greater than 1. So the Pythagorean triplets will be always in the form 2m square plus m square minus 1 whole square is equal to m square plus 1 whole square. So the number should be in the form 2m, m square minus 1 and m square plus 1. These forms the Pythagorean triplets. Okay children. Now let us take one small problem and check it out. So here is a problem. Write a Pythagorean triplet whose smallest number is 8. Okay, out of 3 numbers, the smallest number is 8. You have to find the other 2 numbers. Just simply I am equating 8 to m square minus 1. Send 1 to this side, 8 plus 1. 9 you will be getting, m will be equal to root 9, that is 3 we will get. So that time 2m will be 6, m square plus 1 will be, m square is 9 plus 1, 10. Just to check it out here, 6, 8, 10 we are getting, but 8 comes in the middle. But they are saying 8 is the smallest number. That's why 8 should be equalized to 2m here. For what you should equate? 8 should be equated to 2m. So now send 2 to this side, 8 by 2, 2 ones are 2 fours are, m value we will get as a 4. So m square minus 1 will be m square means 4 square minus 1. 4 square is 16 minus 1 which is equal to 15. In the same way m square plus 1 will be 4 square plus 1, that is 16 plus 1, 17. Now we got 8, 15 and 17. This is the Pythagorean triplet. Clear? So related this, we are having one more exercise 5.2. What the problems you will be having, let us check it out. So the first main contains find the square of the following numbers. 32 and 71 they are given. So 32 square, split it. Because check the unit place, if it is not 5, you go for an a plus b whole square form. So 32 can be splitted as 30 plus 2 whole square, which can be written as 30 plus 2 into 30 plus 2 2 times. Splitting 30 into these 2 numbers, again plus 2 into these 2 numbers. Now 30 into 30, 30 square, plus 30 into 2, plus again 2 into 30, plus into plus plus 2 into 2, 2 square. Now 3 3s are 9, 1 0 will become 2 0. Easy way of squaring. 3 2s are 6, 1 0 as it is, 3 2s are 6, 1 0 as it is, 2 2s are 4. Add all this. So 900. 60 plus 60, 124. Add it up, 4, 2, 9 plus 1, 10. So it is 1024. So one more number I have taken, 71 square. How to split it? Yes, 70 plus 1 whole square. Again 2 parts. 70 plus 1 into 70 plus 1. Again 70 as it is, 70 plus 1 plus 1 into 70 plus 1. Multiply. 7 into 70, 70 square, 70 into 1, 70 plus 1 into 70 plus 1 into 1, 1 square. 7 sevens are 49, 1 0 will become 2 0. 70 into 1 is 70, 1 into 70 is 70, 1 square is 1. Add all this, 70, 70, 140 plus 1, 141, add that to the 4900, 1, 4, 10, 5, 5041 we are getting. Now next Pythagorean triplets related problem. So here 2 numbers they are given, 6 and 18. So general form is what for Pythagorean triplet? 2m, m square minus 1, m square plus 1. Let us equate 6 to the 2m. That time m value we will get as a 3. M square minus 1 will be 3 square minus 1, which is 9 minus 1, 8. M square plus 1 will be 3 square plus 1, 9 plus 1, 10. So the 3 numbers will be given number 6, 8 and 10. This is one triplet. Okay, second problem we will take, 18 we will take. 18 is a bigger number, so I am equating this for a second number, n square minus 1. But what it become? Minus 1 comes this 19 plus 1. 18 plus 1 is 19, whereas 19 is not a square number, so it is not an integer. Now let us equate m square plus 1, 18 to m square plus 1. That time also m square is equal to 18 minus 1 you are getting, which is equal to 7. Even it is, because m square is 17. 17 is not a square number. We are not getting an integer. That's why we can't equate 18 to this. Then for what we can equate? We can equate this to 2m. Okay. For 2m you equate. 2m is equal to 18. M will be 18 by 2. 2 ones are 2 nines are. So 9 we are getting. So m square minus 1 will be 9 square minus 1. 81 minus 1, that is 80. M square plus 1 will be 9 square plus 1, that is 81 plus 1, 82. So the triplets are, what are the triplets you are getting? 80, 80 and 82. So this is the way. Now in the next class we will find how to find the square root. Okay, that will be discussed in the next class. Thank you children.